All right, everybody, let's head back to the afternoon session. This is quite dense, so please fasten your seatbelts and let's start quite quickly. Nice to meet you, Axel NAUMANN. Thank you for joining us for the first keynote of this afternoon on building a strong open source ecosystem for European independence. I'm pretty sure you saw the news during the night, and this will be maybe part of your talk. You are the OSPO of the CERN Open Source Physics Project. You are the head of that initiative. This is an initiative by CERN aimed to promoting the use and development of open source software in the field of physics. This project allows researchers and developers to collaborate, share tools and resources. Maybe you can tell a bit more about that and then go straight to the question of the European ecosystem. You have 20 minutes starting now.
Okay, thank you very much. Thank you very much for the invitation. It's a pleasure and an honor to be here. I have to disappoint you. There's no way that I can do the title justice that my slot has. I cannot tell you what we need to do. But what I can do is entertain you for 20 minutes with stories that do give some aspects of an answer, or so I hope. So let's do that. I'm a physicist. I do not know the things that you should know to make the kind of policies that we need in Europe. But I can tell you where we are coming from and how that might help Europe. So CERN is a giant laboratory for physicists. It's really, really large in a wonderful place on Earth, near Geneva. And we needed to build this giant accelerator, and people were smart enough not to put this on the ground, but below ground where it disturbs people less. We have this large accelerator called the LHC with multiple experiments. What I want to tell you is that we're coming from an organization that is doing collaboration since its beginning. This is the theme of CERN, to collaborate. Founded in '54 as an international organization already, we're doing fundamental physics. So we do not do policy, we do not do AI. Von der Leyen wants to have an CERN for AI, but that's not us. We're the original boring CERN, we just do particle physics. This is a wonderful graph of our connectedness. It shows where the data is flowing, where we're using compute centers around the globe. So it gives you an impression of how much CERN is embedded in the world and in the world of science. We have a very special setup that allows us to experiment not just in the physics areas, but in other areas that we need. I would say it's based on trust by our member states. Thank you very much for your taxpayers' money. We appreciate this a lot. We do physics with it, but we also do other things. And with the freedom we have, we're quite creative in trying to address problems that we see. When we see problems, we really try to sit down, analyze the problem. We have problems we have projects that last over decades. So the solutions we need to find need to be long-lasting. We need to own the solutions. We cannot rely on other people to provide them to us. We need to understand them. We need to be able to adapt them ourselves. Oh, that is very unfortunate. I was trusting the technology too much here. So I'm showing you wonderful slides that you cannot see. But now you can imagine wonderful slides. I don't know, maybe we can fix them. I don't know what to do. I can show you the laptop.
Is Michel Marie here? Can we show the slides?
Yes, thank you very much.
All good. Thank you.
Can I steer this? Yay, I can even steer them. So now that's the optimum. We couldn't hope for more. Okay, so this is what you have been missing. Fine, fair enough. Here comes the story time. So as an example, and I told you I'll entertain you with a bit of stories, we have this giant underground tunnel, and sometimes things happen down there. And because we send particles around, we cannot go there as humans. So we need machinery to come in, see what's happening, and sometimes maybe extinguish a fire. When this was discussed, people were like, oh wait, we have this old rail in the ceiling of the tunnel, because we reused the tunnel from an early accelerator. Back then, that was used for a train. We don't use this as a train anymore. There is no train. But we could use it to have a robot hanging down there that just goes places, and then if there's a fire, it extinguishes the fire, or at least it gives us video images of what's happening. And because we're physicists and always a bit playful, of course, this thing then also got a blue light that is completely useless just for the fun of it. So that brings us to open source. Why do we care about open source? What we do is really convert money into knowledge. That's our job. And I think we're quite efficient with this. And one of the reasons is that we want to have participation from everybody. We're very open. For research, sharing is a prerequisite. So if you look here at the open science element, at the open science elements at CERN, you can find open data, open source. There are things like research, assessment. All of these are elements of the openness of CERN. And so maybe it's actually a surprise that it took CERN decades to start an open source program office. We now have one. It is much more visible than we expected. We expected that we do some internal work, help the project, but actually the world noticed. And the reason might be that actually we have a large community throughout the world, but also we have a lot of tradition. I don't know what to do here again. We have a lot of tradition with open source. So you all know the www, you know, the World Wide Web thing. You used it probably today. That comes from CERN. And it's the story that we tell everybody, but it's decades old. Now I'm going to tell you something that is even older. It's about 20 years before the OSI defined what open source is. I found a letter, an old colleague of mine gave me a letter which shows exactly what this is about. And I think this is core for Europe. So open source allows us to share products that we create and allows us to build upon them. And this shows in this letter from '78 already. Here it was still with Russia. Okay, fine, politics change, but the model still stays the same. And if you look at our open science policy, it's about dissemination, it's about collaboration, it's about open science as guiding principles. What we want is to increase accessibility and participation. Participation is the key element here. I cannot underline enough how important this is. And I cannot underline enough how difficult it is, especially if you're coming from an area of the world which is not resource rich in terms of money, but maybe in terms of brain power only. It is very difficult to have access to the main centers of research. We need to guarantee lifetimes of 30 years. We need to enable access also for future generations. We are building the next generations, we are educating them. They need to be able to make use of what we have done. Now, that brings me now to AI, or as we actually call it, machine learning. We are not selling anything, so we're not calling it AI, but in the end, it's the same. It is just part of our tool chain, so we are doing this actually since quite a while. And we're doing this for understanding what nature is showing us in the detectors that we have. For modeling, we also do Gen AI. We try to build foundation models, but that's for one of the instances of active R&D. So we can identify interesting particle collisions because we have way too many. We can have controls for the particle accelerator. I mean, they're flying with the speed of light. There's no way that humans can react, so it's good to have machinery that allows us to help. We have basically a playground for us to understand AI with numbers, how easy it is to build foundation models that have a relevance for science. And then one of these playgrounds is a weather model that we built together with the European Center for Medium Range Weather Forecast. I think it's one of my favorite titles for a European organization called AtmoRep. It's really fantastic. So if you manage to fire up your favorite search engine, have a look at it. This allows us to test drive what it means for a science to use AI and foundation models specifically. So invest large amount of GPU hours. Here we're talking about 6 million, if I remember correctly, and come out with a model that is actually then tunable for different questions to help different research areas. We're using AI to generate synthetic data, and we have a live review where, you know, an ever-growing list of research achievements that we keep. So here is, I guess, why you're sitting in this room. What can we distill out of this as a vision? We've been hearing about what is open source AI today, about the definition of this. And what I can tell you is that for us, data analysis needs to be shareable, accessible, and repeatable. So we heard this before. I don't want to stress the repeatability part too much. This is not the point. The point is that if you so it's not about actually repeating the data analysis. It is about being able to do it theoretically, because that gives you the trust that the whole chain of training the model, inference, the model itself, is something that you can trust, that has been vetted by people who know this domain. We've heard about the problem of cancer research. How can you trust a model without sharing the CT images of millions of patients? Well, again, if you can, that's fantastic. If you cannot, you need to find a way so that people can still trust these models. So for me, open data and being able to repeat is a question of trust in the models. We have basically everything open source. We are very lucky in that respect. One of the key elements that's missing, and frustratingly so, is AI. So what we do is we are trying to help this. We are trying to contribute to the open source AI ecosystem. So this could be a model, right? We could train a large model, and we share this with the world, open weights. But that's not what we want. It's pointless. It's pointless in so many ways that will become clear when I explain why we do it differently. What we want is trusted and documented training data, because again, trust is the source of this. Even for scientists, we need to understand what we're discussing, whether we can understand the data that we're looking at. We want community-driven models, and we want accessibility for fine-tuning. I'll go into these different parts. These are really the three key elements for us. So open data is a privilege for us. It's fantastic that we have it because it helps us. It makes it easy for us to share data. It addresses things like license, curation, authenticity, and authority. These are all solved. We know who owns the data. We know the description of the data. All of this is there thanks to the open data community. All of these problems have been solved. We are working towards making the data that we have more accessible to AI researchers. And here I'm not just talking about physics data, I'm also hoping that soon we can include much of the additional data that we have. You can imagine CERN as a small city. We have our own banks, we have a little supermarket, we have green areas that need to be maintained, we have electricity that needs to be managed, all of these things. So in principle, what I'm hoping for is at some point CERN can share all of its operational data as open data for the AI community. The second part that I was mentioning, or the third actually, is accessibility for fine-tuning. I think it is extremely important to enable the scientific community to be able to reuse and not just redo the model building, especially for foundation models. Here we want to save energy, we want to reuse the expertise that goes in, we want to centralize, we want to create synergies. So fine-tuning and retrieval augmented generation are a must for these kind of things. We need to enable these. If we have this, then actually we can base on top of a common ecosystem. We can build this ecosystem together, but we can still have specialization. Specialization is absolutely important. It's what you would call competition in the market. For us, that is what gives scientific progress. You can try things out. We heard about the experiments you want to do with AI this morning. This is exactly what this is about. You need to enable this. Here is the key element, which I think is fundamentally important, the second of the list of 3 items that I mentioned. We need to learn from open source communities how they evolve software projects. And we need to adopt the same model for evolving models in AI. The model building itself needs to be a community effort. If we do not do this, we pay in terms of bias, in terms of energy. In so many terms, we create borders that we don't want. We want to have this synergy, this collaborative spirit and effort that goes into building models just like we build software. The evolution of the models, how do we retrain? That should be done by a community and not by a single person who happens to get access to millions of GPU hours. For us, this might be a plausible path. We don't know. We have just started this journey, especially for the foundation models. This is still something that we're investigating. For us, one of the main problems is actually a philosophical one, I would say. It's too bad that I missed our field metal speaker this morning. I would have loved to discuss this with him, because what we need to predict is actually physics theory and not reality. If we train our data if you train our AI with reality, we gain nothing. So that is a challenge that we have that most of the other people don't have. Lucky you. What we also do is we use scientific collaborations to verify one another's results. So also that is a bit of a challenge. We generally don't share our data because we want to make sure that no other party is influenced by some first-party measurement. What we certainly want, what we need is the community to converge. To create the synergy that I was talking about before means that we have to have some grassroots efforts probably where first universities come together, first labs, and start this effort. Now, we might be on the way a bit, actually, because what we have, for instance, is a common framework for ML inference on FPGAs, which is open source. That is really fundamental for us. We have data analysis and statistics with AI. We have training of AI and detector readout with AI. All of these things are sort of done in-house, and we try to make as much open source as we can. We can do a lot, but there are limits to this. Now, you could argue, why do you do this? Like, why is CERN even investing in these kind of things? It's pointless, right? You're competing with people who have billions of dollars that they can just buy GPU hours for. But we're not that small either. And I'm telling you that not because I think that we should show off. I'm telling that to you because I think many of you out there are in a similar situation. If we're talking about weather, for instance, or biology, these are areas which also have enormous amounts of investments. And here is an example from our space where you would say, why the hell did they do this? And the reason is because it saves us money. So we have a small team of people who re-implemented the data format that we use in high-energy physics over the course of 4 years or so. And that is what is going to be used for the next, I don't know, tens of exabytes probably for the community. It pays off to do certain things yourself. There is no point to give up and say, oh, but the industry has way more money, they have the experts, it's pointless. But then when can we succeed? In my point of view, there are a couple of criteria. One is you need to address an actual problem. It's not about just redoing what somebody else did with billions of dollars. That might not be as successful. But if you have a problem, an area that you need to solve, then why don't you give it a try? It should be generic enough, on the other hand, such that there is sufficient scope, sufficient interest, people buy into it. It must be relevant, and then also cost effectiveness, of course, rises if you have a higher scope, a larger scope. Another key ingredient, I hope that is something that we can convey to our policymakers, is that we need to have funding and vision to guide this innovation. That is a key element that we cannot just provide ourselves. We can do it to solve our own problems, but as soon as we want to go out, as soon as we want to go onto a European level and address something on the society side, then we need to have support from policymakers for this. I know Christmas is over. though it's still kind of cold, no? So here's my wish list. It's not CERN's official wish list, but it is the wish list of people doing AI at CERN with the experience of software development for decades, longevity of projects. These are the things that we need and that we hope for to see in Europe. Part 1, sustained funding for open source AI tooling for the ecosystem of tooling. What we hope for is that the EU helps startups for production-grade tooling. This includes drivers, compilers. It includes specific libraries for accelerators and so on. So not accelerators as in particle, but AI accelerators, math accelerators, these kind of things. And to be honest, that's already it. Because I'm convinced that everything else can be built on top of this. And we have enough creativity, enough brain power in Europe to use this, to make use of this, and to build on top. But if this foundation layer is missing, then we have a huge fundamental layer where we depend on other people giving us access and defining the prices. If we have this fundamental layer open sourced, then we can have an ecosystem that develops around it. We will have industry and research favoring this because it's vendor independence. They can use this, they can adapt it to the next generation, to a different vendor. It is exactly that everybody is missing at the moment. We all sell our souls, and I'm not telling you to which companies, but you know to which companies. Having a common tooling enables a common ecosystem. We could all build together on top of this. This is not a dream. I'm not doing your Martin Luther King thing here. We had this in the past. Remember, we had common compilers that enabled industry to strive, to flourish, and we could have the same thing here. I was expecting numbers. You're just looking at me. That's nice. Okay. There's no need to interfere with the higher level creativity. For me, the base layer is the most important part. And here's the conclusion.
Thanks.
So research favors open source. I think I told you why. I maybe gave you an indication, maybe you believe me, how important open source is for the research ecosystem in Europe. Research on AI and applying AI is currently suffering from vendor lock-in. And it's not just the fact that we only can buy from one vendor. It is also that we don't know what's going to happen in 2 years. We are completely at the will of these vendors. There are different uses of AI in sciences. We actually don't use LLMs as much. I think that's more a society thing. We use lots of numerical AI. But it is an ongoing and fascinating bidirectional evolution. We're influencing AI. AI is influencing us. And I'm curious to hear what such a presentation will look like in 5 years. I really hope that we have addressed the open sourcing of the tooling layer. Thank you very much.
Thank you.